Hi, everybody. Thanks for joining us today. Appreciate it. I know there's a lot of competition for great sessions, so thanks for coming to mine. My name is Dave Mariani. I'm the CEO and founder of AtScale. We're a stealth mode startup that's working in this area. Before AtScale, I ran engineering for Clout. Before Clout, I spent 3.5 years at Yahoo. So at Yahoo was really sort of a great experience of being there at the time when Hadoop was being invented. And I ran the engineering for the analytics pipelines, so both for the audience side and the advertising side. Before that, in various positions doing big data analytics, mostly for marketing applications. So what I'm going to talk about today is that a lot about how BI fits with this Hadoop infrastructure. I started my career in the late 80s. And in the late 80s, before there was the internet, I remember hearing about this mysterious thing called relational databases and this company called Oracle. And at the time, of course, we all were dealing with flat files. And so relational databases sound really mysterious. Well, that was in the late 80s. And so flash forward 30 years, and we're still talking about relational databases. Except there's a new game in town. A new game in town is Hadoop. And I just think that we all need to realize the gravity of this point in time, because the same kind of transition that's happening right now, and we're living it, was the same type of transition that happened from flat files to relational. And so what I'm here to tell you about is that with any transition, it means disruption. And with disruption, it means that old ways of doing things need to be replaced by new ways of doing things and new tool sets and new techniques. So one of the things I've noticed in my time working with Hadoop and with BI, business intelligence, is that we've been making sort of like applying the same sort of techniques and processes to the Hadoop world that we've been trained to do on the relational world. So I'm going to give you a couple examples today of things that we did at Clout and for some of our early customers for how we really changed the game in terms of how we do data warehousing on Hadoop. So let's get started. So the truth about data. You guys all probably have seen this statistic, and you'll see it probably 100 times this week. So I'm not going to drill down on it too much, other than to say that what we've been doing for the past 30 years is really focusing on just the tip of the iceberg. The difference is that between the 80s and now, we've seen the area below the waterline grow really dramatically. But guess what? We're still looking at about the same amount of data above the waterline. And that's because we're still using the same tools and the same processes to analyze and make data available to people who can do something with it. And that's just wrong. It's wrong because data is growing too fast. That's a lot of data. It's big numbers. And we need to change the way that we actually handle data. So a little bit of a history lesson. When I started, and probably a lot of you guys have gone through these transitions where you try to build this big, grand data warehouse. I can't think of one company I've worked with who actually has one data warehouse. But this was the idea, right? The idea was we're going to create this centralized repository, and everybody's going to come, and they're going to feast on that data. And so all the data in an enterprise, whether it be supporting marketing, sales, products, whatever have you, with all the different use cases, we're going to be able to come in and allow people to access it. But what we got was this. We got a bunch of data marts. And it's still happening. And you know what? I think it's just it's what we had to do to make things work. But it's not really what we wanted. So we're all pretty sad about that. And basically, the reason why that failed is that we failed on really what we call the three V's. The data was there's too much variety when it comes to all these different types of data. So what happens is that we spent years, months and years, trying to normalize data to fit and make it cohesive so that it can be joined together. So the variety was much too rich to be able to handle in a single relational rows and columns type of architecture. The velocity was too fast. We couldn't write the data enough. We couldn't write it fast enough. We can't load it. We can't take it from its raw form and rewrite it and put it in the form that makes it queryable. So it's it makes it so that we had to sort of take each data stream and put it in a form where we could isolate it so that we can make sense of it and get around those problems. So what's the new approach? Well, the old approach is this. And the three-step process is really simplifying it, right? I mean, it's not a three-step process at all. But essentially, we have an activity where we're capturing data, and then we go through ETL, extract, transform, load, ETL. And then we actually put it into an engine that can be queried. So in the process of doing that, we're rewriting the data many, many times. At Yahoo, our data would come in it would be captured by our ad servers or by our log files when people are visiting the properties. It would get written there. It would then get written to Hadoop. Then it would get written to Oracle. Then it would get written to SQL Server Analysis Services. And then it would get written to, and then it would be displayed or exported. So right there, we actually have taken the same bits and rewrote them at least 4 times. That's craziness. And it's very structured data. We're still forcing them into this rows and columns approach, which causes all kinds of headaches. Because now we have to think about ahead of time what we're going to query. So when you create structure, you create rigidness. When you create rigidity, you prevent flexibility, which means anything you want to do, anything that changes in requirements, cause you to have to go back and do a lot of refactoring. The early transformation is part of that. So we're stuck thinking about what data is worthy for analysis. And at Yahoo was our whole mantra was, hey, you never throw data away because you never know how you're going to use it. So let's not worry about transforming the data and loading it now. Just throw it out on disk. And to throw it out on disk, we had to invent Hadoop because we were going to bankrupt the company if we just kept throwing it on disk. So this is the new way. And there's subtle differences, but it's really important to call out. We always will have to capture data. The difference here, though, is that we're just mapping it, transforming it, and querying it. You notice that there still is a T in there, but there's no E and there's no L. We're writing it straight to Hadoop, which means we're writing the data once. We're dealing with all kinds of different data because we're not worried about its structure, which means that we can capture log files the way log files are written, the way that application logs are written, which is going to be in JSON or XML or whatever the native format is of that data. Forget about transforming it. Don't worry about how you output it. Just throw it on disk. We'll worry about it later, and I'll show you what I mean by that. So that's a better world. But we're still dealing with this process. So here's what we do today. Today, we take our input data. We may write it to Hadoop. We do some ETL on it, maybe lots of ETL on it. We send it to some data marts. We load it into some query engine and take your pick here. Any of the query engines that have grown up over the years, they're just basically extensions of relational technology to try to keep them a little bit behind the curve when it comes to data growth. And then we get to visualize it. That's way too complicated. So here's what I see. Today what I see is that we're still mapping, we're still doing data warehousing, we're still doing analytics the same way. We're using Hadoop as a big ETL engine. That's a waste. Because you know what? Get rid of ETL, get rid of those data marts, get rid of that query engine, because this is how it should look. And before, and this wasn't even possible a couple years ago because Hive was still a batch tool and it wasn't interactive. But think about what Hadoop is. Hadoop is a massively parallel shared nothing architecture. It means that there's shared nothing on CPU, RAM, and disk, which means theoretically, if it's shared nothing, I can do scans that are commensurate with the number of nodes in my cluster. So guess what we have right there sitting there in front of us free is we have an MPP architecture, an MPP database. And it's not a proprietary cluster, it's an open source cluster. So why aren't we using it like that? Why are we just writing ETL jobs and sending the data off someplace else for analysis when we could be using Hadoop as an MPP warehouse? So I'm going to tell you a little bit of examples of how we did this. And I'm going to first start with Clout. So what is Clout? Clout is a social data service. We have consumers. Consumers would come to Clout.com. They would connect their social networks, and we would help them improve their effectiveness in social media. We give them a Clout score. We allow them to post content, and we tag them when it comes to their expertise. So in order to do that, it's a pretty complex data problem, because what we'd have to do is basically connect 15 different social networks and collect data from 15 different social networks, including Facebook. So at Clout, at the time, we collected about half of Facebook's data. So, with little old Clout, little old startup, I couldn't afford to buy expensive SANs and EMCs like I had at Yahoo, where we had resources. So I had to do everything on the cheap. So it was lots of data that we had to capture. We had to score a lot of different new users every day. We had 400 million users that we'd have to score every day. So what's that mean? That means that we're going to take 12 billion different signals. So think about what happens in social media. Every time there's a tweet, there's a post, there's a comment, that's a signal. And so we're collecting that across the social web, and that results into 12 billion new signals a day. That's 12 billion new rows every day, which ends up into serving 50 billion API calls. And it ends up with a warehouse with 1 trillion rows. That's just for 90 days worth of data. So 90 days worth of data at 1 trillion rows. 1 trillion rows. And guess what? Guess how I did that? I did that with all open source technology with one exception. And there's going to be a test on this because there's something wrong with this picture, and I'm going to come back to it at the end of the presentation. So what did we use? Well, we used plain old MySQL for our registration data because we needed ACID compliance, right? We needed a database that was OLTP. We used HBase for serving those profiles because HBase is a great store, key value store for saying, hey, I need a Clout ID, get me all those people's, give me that Clout members profile, and do it all within 40 milliseconds. So HBase was great for that. For search, we used Elasticsearch. We used MongoDB to be able to track people's streams because we had to look at them from different angles, which means we needed indexing, which is why Mongo was there. But the whole data pipeline was all done with Hive. And with Hive, we're talking about 150 nodes, which I thought was ridiculously funny and small compared to, I was used to 4,000 nodes at Yahoo, like multiple 4,000 nodes. It's like 150 nodes. We're ants. But 150 nodes at $3,000 a node, that's $450,000 for our whole infrastructure. I would spend that at Clout. For 100 terabytes, I would spend $500,000 versus 1.5 petabytes at Clout for the same price. Craziness. You're going to notice that for analytics, we use SQL Server Analysis Services. Why? Because I still believe that a OLAP view of measures and dimensions, rather than forcing users to write SQL, is the best way of allowing self-service analytics, of allowing people and the people that can make money for your company. The people that can make money for your company don't write SQL. So I liked analysis services because I could connect it to Excel, I could connect it to Tableau, and they could go crazy, and they can create crazy visualizations and make tons of money, and I never knew what they were doing. All I did was put the data out there in front of them. It works really, really well for that. You're also going to notice there's some stuff down at the bottom here. We're using Tableau for dashboarding. We also have, we built some of our own trackers, and I'm actually going to talk a little bit about the event tracker right now. So I'll come back to this slide a little later. So here's the problem that we have with Clout. So I have this big data service. I have 400 million people that we're scoring every day. And the problem is that I couldn't tell who was using our site. So I knew everything about these users from a social perspective and what they were doing on the social web. I didn't know whether they were coming to using our app, our mobile app. I didn't know what pages they were visiting on our site. I didn't know whether they were even coming to our site. All I knew is that we had, a certain amount of people coming from Brazil and a certain amount of people coming from North America. And so the problem is that, using a tool like Google Analytics, it's great, except that all that data and the data they're collecting is getting completely the keys, which means who those Clout users are getting thrown to the wayside. It's being dropped on the floor. So we use Mixpanel. Hey, it's better, but being dropped on the floor. I had no way of knowing and being able to connect my user profiles that I had built on the social website to the profiles that were built for people who were coming in and working with our data service and with our products. So what we decided to do is that we actually need to know about what our users are doing. And so what we did is we said, you know what, we're not going to throw that data away anymore. Because letting Google Analytics collect it or Mixpanel, that's throwing data away. Really important data for us. So we decided that we were going to cross the streams because we needed a complete view of this activity. So this is what it looked like. So now I'm going to take you through each piece here. So I'm going to first take you through the instrumentation side. Then we'll talk about the data collection, persistence, query, and then finally, reporting and analytics. So this is what we did. We said, you know what? Our designers and our product designers, they don't want to have to write code. And what's natural to them is JSON. They're working in Node.js. That's the way that they communicate. So let's let them create a very simple tag where they can just basically report or just tag pages or events with simple key value pairs. So in this case, we had this concept of a project and an event, and then after that, it could be anything, all kinds of different properties for those events. So that's the first part of our methodology, is just to create a stream of key value pairs. We use Flume to then collect those and persist those into files in HDFS. And then we created Hive external tables on top of those. Now look and see what's in the red there. You're going to notice there that there's an attribute map and a JSON string payload. So all we did was use Hadoop's non-scalar capabilities to actually take a embedded structure and put it right inline in this table. So what's the difference? The difference is that in relational land, I would have my attributes in an attribute table. So what I would have done is that when I actually streamed the data, I would have had to done all this ETL to say, send this data over here so I can do a join later on and do a lookup and do all this normalization. We said, forget it. Just play the data where it lays, throw it in its natural form, and we'll worry about it later. So we've already done something different here in that we haven't taken data and put it into rows and columns. And the difference in what happens is that when I map these to my BI tool, this is a SQL Server Analysis Services, what you're going to see here is that There's the projects dimension, there's an events dimension, and there's a properties dimension or attributes dimension. So it's a very, very simple model, but that model is a virtual model. They're virtual dimensions. They are completely morphable as my data changes. So as a new designer decides, you know what, I want to create a new event because I want to track this new feature. And you know what, I now want to track, the location of the person, where they came from, and also the time of day. New attributes. They can do that, and they never have to talk to anybody. And the person, the analyst who's going to be looking at those properties and those new events, they magically show up. Because what I've done is I created a structure with key value pairs and mapped them to dimensions and used the power of Hadoop to query that in place without having to create all these additional structures and steps to actually spell those out ahead of time. So what I then do is I can create an MDX query in this case, or I can create a SQL Hive query. And check that out. What I'm doing here is I'm just using the getJSON function to actually materialize, in this case, the Clout ID, I think, on the fly. You can see that there's a version, there's a status. All that is just in that JSON text payload. So I'm materializing it as I query. So some people call this schema on read. I call it just-in-time transformation. But what it means is that now I can query this. I created a queryable store without creating all the overheads of having separate tables for all these objects. And there's my predicates and everything else. So I've created a structure that's highly flexible that allows me to change the business without changing the analytics pipeline. So that's all good. But what's wrong with that picture? What's wrong with the picture that I showed you before with the Clout architecture? That's what's wrong with the picture. What's wrong with it? I can give you a couple things that are wrong with the picture. I can give you 3 things. Number 1, having to feed a cube, I'm taking my 1.5 petabytes and I'm shrinking it down to 1.5 terabytes. I'm throwing data away. I violated my own rule because analysis services, the great product that it is, can no way ever handle 1.5 petabytes. At Yahoo, we built the largest cube in the world, and it was 25 terabytes. I'm embarrassed to say that because 25 terabytes is nothing. I can get that at Fry's. But that's the state of the art. That's the state of our BI infrastructure and our BI tools. That's what they can handle. Another thing that's wrong with this picture, Windows in a Unix stack. I can't tell you how much they made fun of me. My team was like, "You Windows guy, oh, you're just a Windows guy." I'm like, come on, it's like, look, I don't have a choice. This is what I can do, and I still want to allow my users to do self-service analytics. And they can't do that if they have to SSH into your terminal and fire up the Hive command line and run queries and then wonder how they're going to get the data off of that workstation. It's like, that's not going to work. So we got to do something different. The other thing is operational complexity. So now I got to worry about when am I going to refresh it because it's out of date, and now I have to go through and make sure it gets updated, make sure it's in sync, make sure it actually ties out and makes sense. So it was a lot of work. Let me give you another example. So this is for an online gaming company. They have lots of players. So what they're trying to do is, they're trying to maximize revenue by making sure that they can give people the opportunity to buy virtual goods. So they want to create opportunities for that and maximize that. And they want to make sure the game is fun to play and not too easy and not too hard. So there's two types of people. There's the game designers who want to build a better game, and there's the money guys who just need to make money so they can afford to pay for the game designers. So this is what we did with them. Here is, and maybe hard to see, but here is an example of their log file. It's just tab delimited, and I color-coded it here, where you could see that there's an event You can see that there's a login and a buy event. There's a simple Unix timestamp. There's a user ID who created the event. And then there's a bag of attributes associated with those events. So first of all, you can see it's very much a log file. It's not where the columns are variable. I could have 100 attributes, or I can have 1 or 0. So what do? We create an external table in Hive, and we create basically a four-column table. We use a map for that attribute, key value store, and now I've actually created a model that's n-dimensional. So I can create as many dimensions as the game designers or the money guys throw at me, and the model doesn't have to change. Because when I query it, this is what it looks like. I can push down those transformations in line to the query. So you can see that for the location column in that map, I can materialize it just by accessing the key, which is location, in that column called event attributes. Again, I've taken advantage of the architecture of Hadoop to give myself flexibility to be able to handle all kinds of semi-structured data. So, how is this even possible? Because I know what you're saying. You're saying, oh, that's too good to be true. No way that's ever going to fly. It won't scale. Hadoop's not made for interactive query. Forget about it. That's a pipe dream. Well, this is great, because to the rescue are the Hive. I call them the Hive flavors. And the commonality in these Hive flavors are that they're all Hive catalog compatible, which they're mostly Hive DDL compatible, mostly. The difference is that you don't have to bet the farm on one of them because they're Hive compatible. You know that they will work with your existing Hive data and your existing data in Hadoop. So rather than sending the data out of Hadoop into a proprietary format, where that's the only use for that data is in that proprietary format, now I can interoperate with my data. I can run my pig jobs, my MapReduce jobs, I can run my R jobs, my Mahout, whatever I want to do on the same data. So what's the difference? Well, there are differences, and they all have different pluses and minuses. When you look at Shark, Shark is mainly, it focuses on in-memory with RDDs. Impala is probably the closest to like an MPP database. And it works by having daemons on the actual data nodes themselves and doing direct access as opposed to through Yarn or something like that, although that's coming. Stinger is basically, that's Hive 13 and Tez. So that just hit GA in Hortonworks 2.1. That just came out literally weeks ago. And their strategy there is to make Hive more performant and more interactive. So the story behind all these flavors is that it does make Hive and Hadoop interactive, and then guess what? It makes it behave like a database, like an MPP database. Not just some cruddy database, a real database that you would pay big money for. So you don't believe me, right? So here's some data that came off of that an engineer at SAP ran, and you can see that he ran a benchmark, TPCH benchmark with HANA, and then he compared it to Impala. I don't know if he knew what he was doing here, because the story is, you could see that Impala does pretty damn well for being free. For being free, right? So then here's some data from a client of ours, a big retailer client. So the other thing is that, look, this is TPCH and TPCDS. It kind of repeats the problem that exists where we're taking a relational benchmark and we're throwing it on top of Hadoop. The fact of the matter is, like, running a TPCH benchmark where you have fact tables and dimension tables is probably the absolute wrong thing to do, because real Hadoop data is going to look very unstructured or very semi-structured. It's going to look like log files. It's not necessarily going to be dimensional in nature, but whatever. So here's some real data for a real client, and I want to highlight two things. This is running on Impala. And this is running on Impala, running on a silly little 5-node cluster that we bought from somewhere online. They're super micros and just cheapy little hardware. There's only 16 gigs of RAM, and there's only 4 cores. And this, by the way, is virtualized. So it's running on KVM virtualization. And you know what? The first thing you notice is that, hey, for the small number of rows, you can see there's a combination of facts and dimensions here, that when you look at the execution time, this is more important to me than anything else. Small tables are fast. The problem with Hive has been in the past is that the overhead of starting a query is unreasonable, and that's what breaks it. So if I have to run a query against 520 rows and it takes 30 seconds, guess what? That doesn't work as a database. That never works. But what you can see here is that it's milliseconds. It's still in the high hundreds milliseconds, but it's milliseconds for small tables. And at the high end, in the billion row end, hey, that's pretty good. I mean, look at that. It's like 33 seconds for a billion rows on cheapy hardware. Imagine if I actually put it on real nodes rather than just 5 nodes. So you can see that this is looking pretty good. This is looking feasible. I can actually do real data warehousing and real querying on this open source free software without spending a penny. So I want to give you a real quick sort of demo of Hive versus Impala. So just to sort of bring it home for a second, let me see if I can do this. So what I'm doing here is that I have the Cloudera quick start. So anybody can do this, and if you like to, you can download it as a VM. And what I got is I got side by side. I got regular Hive. So here's Hive, and then over here on the other side I have Impala. So this is not a very interesting demo, but. Let me show you what I mean. So here's the old days, and this is not Hive 13 with Tez. Okay, this is Hive 12. This is old Hive. But if I run this query against, this is the TPCH data. I'm going to run a count star and a sum of the quantity from store sales, and I'm going to go ahead and do that over here. And I'm going to come to my Impala shell over here and run the same query. So what's the difference? Oh boy, there we go. 3.8 seconds. And that's touching, 2.8 million rows. And look at what Hive is doing. Oh God, running my mappers and my reducers, yeah. So that's why it didn't work before. So I can't impress upon you that what's really the game changer here is with these new Hive flavors, with the interactivity that comes with Yarn and comes with these new engines that are built into your distribution, it's time to rethink how we do data warehousing, it's rethink how we do analytics. I finally finished. Yeah. So what's the key takeaways? In case you weren't listening. Here's my advice to you. Capture all the data. Don't aggregate it. You can't disaggregate data. Forget about aggregating it. Just capture the data as much as you can. And if you can't do it for everything, of course you can't. Do it for some news types. Do it some types that you think that might be really impactful or material to the business one day. But don't aggregate it. Don't extract, transform, and load, please. You can save the transform for query time, which means that We do schema on read and not schema on load. Simple as that. Stop loading. Stop sending data out of Hadoop into something else, which is not as good and not as scalable, and forces you to determine what data is worthy. We shouldn't have to determine what data is worthy as engineers. That's for our users to determine. And please query the data in place. Don't keep creating data marts. Nobody wants that. Let's not. We can finally get away from data marts. We can finally start to put data in one place. And I'm not saying there's going to be one big data warehouse on one cluster for the whole company. But you know what? When data is co-located, all new possibilities come up when it comes to my ability to join data across different sources. Possibilities that I never imagined when I first captured that data. So that's my spiel. I hope you go back and you do some wonderful things with Hadoop. Thank you. So we have 5 minutes for questions, if there's any questions that you guys have. Question in front.
I was just curious, it's kind of a orthogonal question. You talk about cost at Hadoop, how cheap it is. I was wondering, do we count electricity and cooling and all that when you go to 1,000 nodes versus having 2 appliances?
Yeah, so the question is, when we talk about cost savings with Hadoop, what about the power considerations and the like? It's I don't know if you've ever, if you ever see an EMC SAN, but you're right that when it comes to one use versus full racks, for a dedicated appliance, you're talking about a full rack. In a full rack, I can get what, 31 U's? So if you do the math, I will bet you that it's pretty equivalent and pretty efficient, especially given the fact that I can pack RAM and I can pack drives, especially high capacity drives in there. But that's a good question. More questions? Question there. So the question is, do you use file formats like Orc or Parquet for your data? Wherever possible, I think I told you just capture data and put it on disk as fast as possible. If you can, in the process of writing that, you can write it in a Parquet or an Orc format, you're doing yourself a wonderful thing because you're getting compression and you're going to increase your query speeds by at least 10x. If you can't do that, don't do it later on the data that you need. But I would say that it's definitely a gigantic difference if you can write it in those formats.
Did the example you give have Orc format?
The example I gave was Impala. It was Parquet. It was Parquet format. The Hive format was when the comparison. So the question is like the Hive. No, the Hive was just against text. Actually, they were both against text in that example. Same format, same files. Another question?
So is your workflow where you set up the external table in Hive and then you sort of like a create table like in Impala as Parquet and then select everything over into it? Is that kind of the workflow that you see?
So the question is, do you use an external table and then do a create table like stored as as Parquet to get a table in Parquet? Yes, you can do it that way. But you can also stream it that way as well. You can actually write it as Parquet to begin with. But for most people, you're right. Doing an external table and then doing a create table of select in Parquet is an easier way of doing that. More questions? What does our product do? So the thing that what analysis services does is that's what we do. But we do it inside Hadoop. So it's an OLAP engine on top of Hadoop.
So you had good query performance on a single query without what were your observations when you had maybe 50 or 100 or 7,000 queries?
So the question is, good performance on a single query. What about concurrency? I can tell you that the flavors, when it comes to concurrency, the flavors differ dramatically there. And we found that the concurrency for Impala is pretty impressive. Still not as good as you're ever going to get for the mature relational databases, but it's definitely going in the right direction. The other flavors have some work to do.
So could you still scale out and add more nodes on, you get more capacity?
Yes, for sure. Good question. Other questions? One more?
How comparable is the performance between Hive 13 TES versus Impala?
So the question is, what's the performance Hive TES versus Impala? I'm going to be politically correct and tell you to go. There's a Cloudera came up with a benchmark that is published last week, and you can go see that for yourself. And that's pretty much what we saw as well. Impala is, I'll tell you, Impala is definitely more mature, and it definitely is doing better right now. And you can see that in the benchmarks. They compare Shark, Hive with TES, and Impala, and it's a TPC DS study. You can go see that online. Anything else? Okay, thank you very much.